So here's the graph algorithm visualizer I created in p5js, and as you can see, the user interface is pretty user-friendly, and there's a couple of buttons down here that is basically everything you will need. Everything right now is basic functionality. I have two algorithms implemented that can traverse this grid. So this grid is a maze that is randomly generated, and you can choose the wall density here and generate a new board to have more walls. So these blocks are walls, and the ones without blocks are the ground. And you can also have no walls at all, or have just some walls. Every time you generate a new board, the wall and the ground will have complementary colors, which is to show contrast. And you can there's a prompt on the bottom right you can follow that will tell you what to do. So right now you can select the starting point, which you can just click on the grid and it will be a red circle as a starting point. And now you can select the ending point, which is a green circle. And now it's ready, and once it's ready you can run any of these algorithms over here on the bottom left corner. And once you click these buttons, run A star, you can see how A star runs from beginning to end throughout the grid to try to find this ending point. And you can also run BFS, which is an entirely different path trajectory. So you can visualize how these different algorithms work their ways from starting point to ending point. And once you're, if you want to choose new starting point and ending points, you can also clear the board and select new starting point and ending point, and you can, it will still find its way there. So BFS works layer by layer, where A star just works from its beginning to end with some heuristic, so it will be much faster. And on the bottom right, you can see the time at which these algorithms run, so you can also compare and contrast the algorithms to learn about them. So now that BFS took 15.2 seconds, and A star, if you look at it, only took 1.8 seconds, which is exponential difference in time. And once you're satisfied, you can generate a new wall, new boards, and starting point and ending point, and you can run them again as many times as you want. And what happens when there's no solution? For example, if the walls are really dense, and you can select the starting point and ending point, and you may not know what the shortest path is, or whether there is a path at all. If you run this algorithms, if there's no solution, it will just end up in some corner of the grid, and it will show you that there's no solution. Same thing with BFS. So they may end up in different spots, but they will also, the result will be the same.